All right, let's talk about something that's, well, one of the most terrifying, absolutely universe-shattering ideas in all of physics. It's called vacuum decay. And yeah, it sounds like something straight out of a sci-fi movie, but believe it or not, this is real science, based on what we know about how the universe actually works.
You know that feeling when you look up at the night sky? You see all those stars, so far away. It just feels so permanent, right? So peaceful and unchanging.
I mean, for almost 14 billion years, it's been this beautiful, stable stage for everything to happen. Galaxies forming, stars being born, and, well, us. There's a real comfort in that stability.
But what if all of that feeling of safety, is just an illusion? What if modern physics is telling us that the very fabric of our reality is temporary?
And that brings us to this really wild and, frankly, unsettling question. Does our universe literally have a delete button? That's exactly what we're going to get into today.
So, a cosmic self-destruct button. And here's the crazy part. We're not talking about some button hidden away in a distant galaxy. No, this is a possibility that might be hardwired right into the fundamental laws of physics themselves.
So how is that even possible? Well, to get our heads around it, we have to totally change how we think about empty space. The answer isn't in anything we can see, it's all about the invisible energy that fills, well, everything.
See, in quantum physics, a vacuum isn't just nothing. It's actually fizzing with energy. It's filled with these invisible quantum fields, which are basically the fundamental building blocks of reality. You can almost think of them as the universe's source code or its operating system.
And the main character in this whole drama is the Higgs field. You've probably heard of it. It was a huge deal when it was discovered back in 2012. This field is everywhere, and it's what gives fundamental particles their mass. So its energy level is what sets the rules for our universe, which leads us to the big, crucial question. Is the Higgs field resting in its lowest possible energy state?
And that's where we get these two possibilities. On one hand, you have a true vacuum. The best way to picture this is a ball resting at the very, very bottom of a deep valley. It's totally stable, it can't go any lower. But then there's the false vacuum. This is more like a ball sitting in a little dip on the side of a much bigger hill. It seems stable, right? But there's a much deeper, much more stable valley just waiting for it down below. The whole scary idea here is that our universe might be in that little dip.
Okay, so let's say we are in that shallow dip, that false vacuum. How in the world does the universe actually fall into the true one? What pushes the ball over the edge?
Well, this is where things get really weird. The push isn't a push at all. It's a bizarre process called quantum tunneling. It just completely defies common sense. See, in our normal world, the ball needs a push to get over the hill. But in the quantum world, nope. There's a tiny, but not zero, chance that it can just, poof, appear on the other side. It's like a glitch in the matrix of reality.
So imagine that tunneling event happens, just once, in one tiny, random spot somewhere in the entire universe. Instantly, a microscopic bubble of the true vacuum appears. And because this new state is way more stable, it's basically the universe's preferred way of being, that bubble starts expanding. And it expands outwards in all directions at the speed of light, completely rewriting the laws of physics as it plows through everything.
And the consequences, they're absolute. I mean, the physicists who first figured this out put it pretty bluntly. In this new vacuum, the fundamental constants of nature would be different. Atoms, as we know them, might not even be able to form. Chemistry would break. The very rules that allow for matter, for life, for us, would just be erased.
And the scariest part? You would never, ever see it coming. Think about it. A warning is just information, right? And nothing, not even information, can travel faster than the speed of light. Since this bubble of doom is expanding at the speed of light, the wall of the bubble would hit you at the exact same instant the light from it. The warning would. There's no time to prepare. The warning and the end are the same event.
Okay, deep breath. I know this all sounds completely terrifying. So before you start canceling your weekend plans, let's actually look at the numbers and see if we should really be worried.
First off, the best piece of evidence we have that we're probably safe is us. The fact that we exist. Our universe has been chugging along for almost 14 billion years. Across trillions of galaxies, this hasn't happened yet. That's a pretty good track record.
And then there's the math. The predicted lifetime for our vacuum state is just staggering.
I mean, the numbers physicists have calculated are so mind-bogglingly huge, they make the current age of the universe look like less than a nanosecond. We are talking about numbers with literally hundreds of zeros. It's a timescale our brains just aren't built to even comprehend.
So why aren't scientists running for the hills? Well, it's because this whole idea is based on something called the standard model of particle physics. And the thing is, we know the standard model is incomplete. It's our best theory so far, but it doesn't explain everything. It's missing gravity, dark matter, dark energy, the big stuff. Any new physics we discover could completely change the calculation and show that our vacuum is perfectly stable after all.
Okay, so if we probably don't need to actually worry about this, then why on earth do scientists even bother thinking about it? What's the point of studying such a bizarre, far-off possibility?
Because the real value here isn't as a doomsday prediction. It's about what this whole idea tells us about the edges of what we know, and what it hints at about the true nature of reality.
And this is the real takeaway. For physicists, this potential instability isn't a threat, it's a giant flashing clue. The numbers we've measured for things like the Higgs boson and the top quark seem to be balanced on a razor's edge. It's almost like they're screaming at us that there must be some new physics out there, something beyond our current understanding that's keeping everything stable.
So in the end, this isn't really a story about the universe being destroyed. It's a story about the incredible mysteries we're just starting to scratch the surface of. Thinking about our universe's fragility doesn't have to be scary. Instead, it can be this amazing invitation to just stop and wonder at the fact that we're even here at all, alive and thinking about these things in this beautiful, strange, and, for now at least, wonderfully stable home.